The next activity is the low friction activity. And to introduce it, we could discuss and reinforce what the force of friction does to movement. It slows down movement. It's a force that acts in opposition to movement, in the opposite direction, slowing down on things. And you could ask the students, so is that a good thing or not? Having friction slowing things down? Most of the time it's not a good thing. So scientists and engineers need to come up with ways of building machines and other things that have low friction, because friction's a bit like the enemy sometimes when it comes to movement. It's good if we want to stop things and not have things be too slippery. So you could ask students to look at the soles of their shoes and tell you what they think the material is that they're made out of, and whether that would have a little or a lot of friction. And it's usually rubber and there's a lot of friction. You could ask, why do we need friction on the soles of our shoes? It's so we don't slip over all the time and we can change direction, particularly if we're playing sport or something. So sometimes we need friction. You can also ask, if they've got a bike, how do you stop your bike? How do the brakes work? Well, they have little pads of rubber that clamp onto the wheels and use friction to stop the wheels. So friction's good for stopping, but it's not so good for moving, and particularly if you want to move fast. So scientists have come up with some ways to cut down the amount of friction, and you could demonstrate this car. You may not have this car in your kit, but it'll be some sort of car, and just ask the students, what design feature does this have that cuts down friction, that helps the car to move really easily? And of course it's the wheels. So we spoke before in the introduction about how there's two types of movements, sliding and rolling. Wheels can roll, so they're a great invention to cut down on friction. Our activity we're going to do is going to look at another way we can have a low friction machine. And so you can show the equipment for the activity. It's just this electric hoverball. I'm not sure exactly what it's called. They're things marketed for playing indoor soccer. Please put them back in the boxes to store them after we've at the end of the lesson, because they're a bit fragile. They have batteries in them, which can be opened up there if they need to be changed, and you should have spare batteries in the kit. They turn on there. So the students are going to experiment with this, to compare how it moves when it's off to when it's on. This will be once again a whole group activity, 10 minutes. And they're also going to be instructed, you should instruct them to think about how this works to minimise friction. So you can demonstrate it on your table, how we can turn it on and see how it moves, and instruct them that when they go to the table, each group will get one, and you will not have this on the table. You will bring it to the table when they do the experiment. And it's probably a good idea not to leave it on the table. Take it back after the activity. For fairly obvious reasons, this is something that looks like something they might want to play with all the time if you leave it on the table. So instructions for their activity will be to have half the group stand on one side of the table, half the group on the other, and to start off just pushing it from one side of the table to the other with it off, and observe the amount of friction. It's sliding. We can see and hear as well from the sound there's quite a lot of friction. It doesn't move very fast. How much force do we have to apply to get it to the other side of the table? Quite a lot. Then they can turn it on and make a prediction how much force will they need to push now, and do the same thing, and they're going to find that they need much less force now because there's much less friction, and they'll be having fun. Encourage them, and a lot of them will just start pushing it as hard as they can without encouragement to try and work out what's the most gentle force you could push it with to get it to the other side of the table. Encourage them, not to just start playing with it. If you think this is going to be a big issue before they go to the tables, it's often good to say, science can be really fun a lot of the time, and this is probably going to be really fun, but we're scientists, we're looking at this like scientists, we want to find out science from this, we're not just playing with it, okay? We're not just playing, we're not just having fun, we're trying to find out about friction. After they've done that on the table, they can do the same thing on the floor, which if you're lucky will be a carpet floor because it's going to give you another variable, a difference in the amount of friction. But even if it's a bare floor and you've got no carpet, you can give them a few minutes to... best way is get them to sit in a circle on the floor, a circle about this wide, a few metres wide, 4 or 5 of them sitting in a circle, and they can do the same activity. They can push it... Now the challenge is to push it a further distance than we were just doing on the table, to push it to the other side of the circle, first without the fan on. And if it's on carpet, they're going to find, they're going to really have to push it hard. I'm not going to push it too hard so it falls off the edge of the table here. And then they'll find if they turn it on, even on carpet, it's very easy for me to push it off too hard. Even on carpet, it's a very low friction device. Once again, if you can encourage them to try and get the least amount of force... Oh, here it comes back. The least amount of force to get it over the other side of the circle. It's a lot of fun. The main challenge with that activity is to get them trying to do some science. And so, discussion afterwards, how much force did you have to use to get it to go the required distance when it was off compared to on? You had to use a lot more force when it was on. Why? Because there was much more friction. When there's not much friction, we don't need much force to move things because friction slows things down. Last bit of discussion. How does it work? What makes it work? It's got a fan in there. What's the fan doing? It's blowing what out? It's blowing air out. How does that create low friction? It actually makes a little gap between... Good to turn it off while you're talking so you don't shout. It takes a little gap between the hover ball and the surface, so it barely touches the surface. It floats on a cushion of air. You can ask them if they know any other things that work like this. I was thinking hovercraft, but a lot of kids, hovercrafts are not the most common kind of thing around, so a lot of them don't know that, but they do know. Hoverboards are a bit of a thing these days, apparently. They knew about hoverboards when I taught this last. So ask for other examples, and then we'll move on to our next activity.